Hello friends, welcome to my channel. This is Strength of Material Part 2 for ISRO 2017 examination. Quick review. Elongation of bar due to own weight or self weight. Omega is weight for unit volume or specific weight, and W equal to weight, its specific weight into volume. So elongation due to self weight is del L. This is omega L square divided by 2E. Or in terms of W or weight, it's 2AE. Area into length is volume, so we can get WL delta L self WL by 2AE. And for conical bar, elongation due to self weight. For conical bar, omega L square by 6E or 1 by 3 into elongation of rectangular bar due to self weight. Rectangular bar. Important is failure theories. For ductile materials, failure stress is yield stress, and theories are maximum shear stress theory and maximum octahedral shear stress theory. For ductile material, these two theories are applicable: maximum shear stress theory and maximum octahedral shear stress theory. For brittle materials, failure stress is ultimate stress, and for brittle materials, theory is applicable as maximum principal stress theory or maximum normal stress theory and Coulomb-Moore theory. List 1 and list 2 matching, they will ask this type of questions. One side brittle material, ductile material, like this they will lay, and failure theories list 2 they will give. You have to match list 1 and list 2. Next is maximum shear stress theory. Maximum shear stress theory, or it is called as Guest and Tresca theory, or simply Guest theory, or simply Tresca theory, or we can call it as stress difference theory. All names are important. Sometimes theory question they will ask, list 1 and list 2 type question they will ask. It's applicable for ductile materials. Failure condition is tau max should be less than equal to tau yield. If maximum shear stress reaches to yield stress, then material will fail. Sigma yield by 2. So maximum of sigma 1 minus sigma 2 or sigma 2 minus sigma 3 or sigma 3 minus sigma 1 should be less than equal to sigma y. because both sides by 1 by 2 by 1 by 2 it will cancel. So this is the expression, and your graph is for maximum shear stress theory. This is also important. Sometimes list 1 and list 2 matching, they will give this type of graphs, you have to match. List 1 shear stress theory, list 2 graphs they will give. Sigma 1 minus sigma 1, sigma 2 minus sigma 2. This is for maximum shear stress theory. Then maximum principal stress theory, MPST. Names are very important, different names. MPST or maximum principal stress theory or maximum normal stress theory are called as Rankine theory. All are important, different names. Applicable to brittle materials. 2 times asked in ISRO examination. Maximum principal stress theory or maximum normal stress theory is applicable to option A, B, C, D, like that they will give. You have to choose the option. Answer is brittle materials. And here material will fail when maximum of sigma 1, sigma 2, sigma 3 will equal to ultimate stress. For brittle materials, failure stress is ultimate stress. Graph is sigma 1 minus sigma 1, sigma 2 minus sigma 2. Like this. This is the graph for maximum principal stress theory. Then strain energy theory or Higgs theory. Sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 mu into sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1 equal to sigma y square. This expression is important. Problems they won't ask you, only this expression they will ask you. Strain energy theory or Higgs theory. This is the expression. One more thing is important here. Strain energy per unit volume it's 1 by 2E. This one you just remember. No need to go for the derivation. You just remember this one, these two. Sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 into sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1. Here mu is there. I forget to write this one. Then maximum principal strain theory or Saint Venant's theory. Principal strain is this one already discussed in my previous video, or you can check my strength of material playlist or machine design playlist. minus mu into sigma 2 plus sigma 3, like this. 1 by E sigma 2 minus mu into sigma 1 plus sigma 3. Failure criteria is maximum of sigma 1, this is not sigma, strain 1, strain 2 and strain 3 should be less than sigma y by E. We know stress by strain equal to E. So from here, strain equal to stress by E. Next is maximum shear strain theory or MDET or Mises-Henke theory or von Mises theory. This is very important for IS and GATE examination also. Best theory for ductile materials. This is important for PSU examination also. Which theory is best for ductile materials? Both maximum shear stress theory and MDET will available in option. Best is MDET. Its expression is, for ISRO you just remember this one. Plus sigma 2 minus sigma 3 square plus sigma 3 minus sigma 1 square equal to 2 into sigma y square. And here I am writing 2 into sigma y square. And one more thing is important here. Total strain energy due to distortion. One by 12G into sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. This is also important. And its graph is, MDET graph is important. MDET and MSSET and MPST, this graph is important. Minus sigma 1, sigma 2, minus sigma 2. First I will write maximum shear stress theory, this green one. Then for MDET, this blue color, this is for MDET. Green color, this is for maximum shear stress theory. And for principal stress theory, it will come like this. This black color, this is for MPST. Thank you friends. Thank you for watching my video. Thank you.